Good morning, ladies and gentlemen, colleagues. Welcome to this PIA seminar. My name is Qingyan Cheng. I am the Director of PUI Academy for Interdisciplinary Research, or PIA. So today we are very happy to have Professor David Pugh to give a PIA seminar. It's very interesting to see the title. You know, I always try to encourage the PIA speakers to talk about their career, but nobody wanted to do that. They are very humble and always try to talk about the professional stuff, and for which I think it's easy to learn from their publications. But to learn one's career is very, very difficult, unless you are political figures, and then you might be writing a memoir at the later stages. But I'm really very thankful to Professor Pugh, who wanted to talk about his career development. David Pugh is a member of the International Advisory Committee of PIA, who contributed a lot to the development of PIA. He is also a resident professor at the University of Minnesota. And at Latin University, he has been the director of an industrial consortium, which consists of more than 60 members. So he's not only excellent in the academic research, but also in the industrial applications, from which PIA benefited quite a lot from his experience. And of course, he's a member of the U.S. National Academy of Engineering. It's the top honor in the United States, and also an academician of Academia Sinica in Taiwan. That's also a very high honor, very small number of members there. So I knew Professor Pugh when I was a postdoc, when I was a PhD student. At that time, he was an assistant professor at the University of Minnesota. I really wanted to work for him, but since I studied in the Netherlands, in Europe, normally we think only professor has money can support postdoctoral research. So I never contacted him. I just tried to contact his colleague, Professor Benjamin Lau at the time. And then I found that really make a mistake because in the US, normally assistant professor has more resources than full professors in many cases. So I missed the chance to work closely with David Pugh. But I'm very happy at my latest stage of a career, and I could have his advice in PIA. So he's really a true friend of PIA. So he's I don't want to read the entire long introduction, and I think today he will talk about himself. So I will just cut this part short. So without further ado, ladies and gentlemen, please join me. Welcome Professor David Pugh.
I should tell you that 我係香港長大嘅，喺度香港讀小學、中學，然後去美國讀大學。所以我的廣東話呢唔錯，但是我的普通話就是太普通了，所以今天我要用英語跟你們談一談哈。So I will share my personal experience of guiding some of my master's, PhD, postdocs. I think many of them are very successful in industry and also at the universities. So I'll show you a few of those. And then throughout, I look at the personal quality of the students and the skill sets they develop under my laboratory that make them successful. So I'd like to share with you some of what I learned from working with them. So now I should mention that I've given a research talk, I think last 2 years I gave 2. So today I'm not going to tell you too much about my research. However, if you're interested, you can go to this two websites to learn more about what I do in my research. So I'm director of the Particle Technology Laboratory. And so here are some of the instruments that I developed with my colleagues and with my students. This is for measuring particle size distribution. This is for measuring particle surface area. And then this too, actually this one is part of my PhD thesis. And they're still using it after 45, 50 years. And so this one, I developed it together with my PhD student, Chen Daren. He's now chair professor at Virginia Commonwealth University. So this is the classifier used for nanoparticle size range. So as you can see, when you plug this into the platform, which measure flow rate and voltage, and then the classifier aerosol come in to a particle detector. And this is the basis of measuring particle size distribution in a PM 2.5 size range. Now, we did a lot of instrumentation development. So all of them need to be calibrated. So we developed method for calibrating the instruments. So therefore, some of those actually become ISO standard. So here are a few that I'm responsible for that. One is for measuring the particle size distribution. And second one is measuring aerosol number concentration. Now, this is important because the European vehicle emission standard now is number-based, whereas previously mass-based is not very sensitive. And for particle, they can continue to press for lower concentration so that you have some question? No, okay. So therefore, all the vehicle emission standard require instrument to be calibrated with this standard. And then my previous postdoc, Wang Jing, and he is now a ETH Zurich professor, and he and I work on the measurement method for testing the filtration media in a nanoparticle size range. And here are a couple of the primary standard that I work with National Institute of Standards and Technology. So 60 nanometer, 100 nanometer primary size that can be related to the 1 meter stick maintained at NIST. So now this is, I go right in and telling you what I did for my PhD thesis. Now this is one of the important work that I have done as part of my PhD thesis. Now, Ken Whitby is the first director of the Particle Technology Laboratory, and he developed this Whitby aerosol analyzers, and it's huge. It's bigger than a big refrigerator. And my colleague like to say that, my German colleague, he said that in the afternoon, when I feel sleepy, I open up this door and go in and take a nap. Well, he was just making a joke. But this is the commercial version of what I developed as part of my PhD thesis. In fact, this is a bench scale, and this one is mounted on a Cessna aircraft. And we actually flew this instrument in St. Louis Basin to look at the power plant plume coming out from the big power plant Labadie plume. So So it's very popular instrument at that time. So guess what? As part of my PhD thesis, I took my prototype unit in this aluminum box and then taking a van to go around California to measure particle size distribution. Now the Whitby aerosol analyzers is in this big motor semi-trailer truck. It's big truck. You see that this is a WAA, this is computer. The two of them basically occupy 1/3 of this trailer. And for me, this is it. And it's operated totally by battery. And then I also have a couple sampler and a particle counter to go with me. And my advisor, he sold me his car. It's a Chevy Nova car. And it traveled very fast. My wife and I drove it from Minnesota to Los Angeles. And sometimes I drove like 120 miles per hour. So it just happened that we get married that summer. So this become our honeymoon trip. So I appreciate that. Yeah. And so this instrument was published and TSI developed it into a commercial instrument. Now, TSI long-term aerosol instrument general manager, he said that WAA, the big one, was not a business success. TSI sold only 16 of them in 6.5 years. So they're losing money. So he said that the president is considering canceling aerosol business. However, EPA, after seeing how well the instrument worked, he want to order 3 EAA. And at that time, the president asked, if we only sell 3, how much a loss we will incur? And then the general manager said that, well, maybe $500,000 US, yeah. And so the president decided, okay, let's go with it. Now, guess what? By the time the instrument is commercialized, TSI received 28 orders from around the world. And then, so he said that TSI would have gone out of business for aerosol without the EAA success. Now, TSI is considered the world's leading aerosol instrument company. In all, I think they sold 300 to 400 of the EAA around the world. Now, currently, it has developed into this SMPS. So you see that we still make use of the 2 classifier that I developed in my PhD. So if you plug it into this platform, measuring flow rate and voltage, and classify aerosol go into a detector, this become the most popular aerosol instrument to measure atmospheric PM 2.5 around the world. Now, as a result of that, many of the measurement, we find that atmospheric aerosol consists of 2 modes, the fine particle modes and the coarse particle modes. And there's a brick around 2.5 micron. So it gives you more details. So here's 2.5 micron, smaller than 2.5 is fine particle mode. It's formed from combustion gas to particle conversion. So it's coming from power plant plume, vehicle emissions, and they have very long lifetime because they are very small. so they don't settle very fast. And so it can be staying in the atmosphere for days to weeks and transport over thousands of kilometers. Whereas larger than 2.5 micron, this is from windblown dust, agricultural construction activities, and those are big particles, so they settle very fast, and so rarely transport over 100 kilometers. So with that, EPA decided to set PM 2.5 standard. Now, 2.5 is a subscript, meaning less than 2.5 micron. So for PM 2.5, less than 2.5 micron. 24-hour standard is 35 microgram per cubic meter. Annual standard has been 12 microgram for a long time, but last year it's reduced to 9 microgram per cubic meter. So if the city do not meet that over a 3 years period, EPA can come in and shut down some power plant and so on. So one of the things that we did, I think that exposed our student to the broad scale of aerosol application is that we have a good partnership with industry. Over the years, we have 2 centers, one for helping semiconductor industry. You see IBM, Delco, Texas Instruments, so on. And currently, we have a Center for Filtration Research. I will show you that we have 18 active companies. So through this 2 centers, we have graduated something like 60 PhDs, and they are very successful in industry and in academia. So let me show you a list of some of them. I cannot show you everything. And okay, so this is Center for Filtration Research with 18 companies now. You see 3M, Boeing, and Korea, Samsung, LG, and Germany, Freudenberg, and then in China, Meidi, and Xinda, Huayuan, and so on. Collectively, they make 50 billion annual sales for removing PM 2.5 engine emissions, cabin air filter for automobile, airplane, respirator, and personal protection equipment. So here's a list of some of my former master's, PhD postdocs. And so Cai Chenjing, he's a chair professor in Taiwan Jiao Tong University. And Zhang Xiang, he got master's degree and went on to UC Berkeley. And then he's now president of the University of Hong Kong. Scott Ernest, director of one of the 4 offices of National Institute of Occupational Safety and Health. And Shong-Gi Che, he was the vice president of Samsung Semiconductor, senior vice president, Samsung Display, and later on senior vice president of LG Display. Yang Yi, senior director of Applied Material. He's from Xi'an Jiao Tong University. And Applied Material is the largest semiconductor equipment manufacturer in the world. Chen Daren is the chair professor at Virginia Commonwealth University. Wang Jing, he is the full professor at ETH Zurich, one of the top schools in Europe. And Se-Jing Yuk, professor Hanyang University. Actually, the Korean students, they are very focused when they come they really study hard and write a lot of papers. So I actually have 7 PhD who are professors in different university in Korea. And then, okay, Shintaro is a Japanese student. Let me show you more. Shintaro received a PhD from me in 2001. And then he started to work for Fujitsu semiconductor manufacturing. And now he is Senior Vice President at Head of Quantum Laboratory. In fact, just 2 months ago, they announced the development of the world-leading 250 qubit superconducting quantum computer. You know, IBM CEO, he said that quantum is the next big thing after AI. So after AI, quantum is expected to be the next big thing. And because it has the capability of calculating thousands of times faster in doing some of the complex calculation. So this is the quantum computer. And guess what? It's a big thing. You see the Japanese Prime Minister Ichiba went and Shintaro explained to him. I think you probably know that he stepped down as the prime minister. So, you know. So in politics, it's up and down. So, but in academia, industry, if you do a good job, you can keep your job. And then Shunki Che, he actually was doing heat transfer. And then I convinced him to do particle technology. And then after that, he become senior manager, VP of Samsung Semiconductor, and then a senior VP of Samsung Display, and go back to teach at SKK University, and then come back and become Senior Vice President of LG Display. And Wang Jing, he is from Baoji in Shanxi, and then he went to Tsinghua to get his PhD. No, Tsinghua to get his bachelor's and master's degree. And then he came to University of Minnesota to do PhD in the aerospace engineering. And so he did so well that he and his advisor wrote a textbook on fluid mechanics before he even graduated. So I was invited to sit into his PhD final exam. And I was so impressed that I went to Wang Jing saying that, look, why don't you come and become my postdoc? And so he indeed came with me. And so fluid mechanics lose a very good scientist. However, aerosol community gained a big name. He is very successful. He has 20-some researchers working with him. One of the work that he did is to test the jet engine, commercial jet engines, to see if they emit nanoparticle gases and so on. So in fact, this become a international standard for testing all the commercial jet engine. And I mentioned also earlier that he worked with me to do the nanoparticle filtration efficiency measurement. Okay, so what are the quality of this or these students that I, by working with them to find out what are the personal quality and what are the skill sets that they have. So for personal quality, it's the passion, independence, teamwork, creativity, hard work. So PITCH, pitch. And then for the skill sets, there's critical thinking, communication, and collaboration, CCC. So I said that the quality is PITCH and CCC. Let's go through each of this briefly. So passion, yeah, all of them have passion. They pursued a research topic with great passion. Think about the topic from morning to night and talk with your advisor and fellow students about your exciting findings and dream about it when you sleep. I think sometimes I dream about my research too, even now. So that's passion. Next is independence. Now, there are two types of master student take order from advisor manager. The advisor manager think for the technicians, the master students, so that no mistake is made. So that is suitable for master's degree student. For PhD graduate, you take advice from the advisor, think independently of how to approach solving the problem. Now, it's totally acceptable to make mistakes and learn from it. Yeah, I make a lot of mistakes during my PhD time that I never forget those mistakes. Teamwork. So yeah, every week I like to take my student to bowling. And now if you, yeah, many of them are professors now. And oh, this guy is a Japanese. He is very shy, hiding behind me. And so if you look at the bowling, all the students, they like to find the biggest bowling ball. For me, I find the smallest bowling ball. I aim for precision. And I almost always win as number one or number two, yeah, because I'm more precise. Creativity. Now, Albert Einstein said that to raise new questions, new possibilities, to regard old problems from a new angle requires creative imagination and marks the real advance in science. So therefore, creativity makes a genius. Now, how about next one? Thomas Edison. He invented the light bulb. He said, genius is 1% inspiration and 99% perspiration. So it's the hard work that carry out your idea and make it successful. So I just talk about the passion, independence, teamwork, creativity, hard work. Those are the personal qualities that I'm quite sure many of you have that. Next, I like to focus on critical thinking, communication, and collaboration. This is the skill sets, CCC. Critical thinking is that when you're doing your thesis, there are many ideas coming from everywhere, but what is important is that you do extensive literature survey so that you can see what is the state of the art. What you don't like to do is to do something that somebody already done it, to reinvent the wheel. So so all this is in your head. So what you need to do is to do systematic review and then focus yourself and objective analysis of the facts to form a judgment. So it's a critical thinking. Next is communication. So I like to give students a chance to write as many papers as they wish to do. So as I mentioned, Korean students, they work very hard. And here's one of the Korean students. He's now professor at Busan National University, a good university. So this is chapter 1, chapter 2, 3, 4, 5, 6. Each of the chapter become one paper, one journal paper. And another one, Zhuo Zili, he worked on a virus aerosol and the filtration of virus aerosol. This is chapter 2, 3, 4, 5. And he also wrote a couple other papers. Now he's a technical fellow of Boston Scientific. It's a major biotech company. Now, one of the paper he wrote with me, Zhuo Zili, is PM 2.5 in China. And this is a hot topic 10 years ago because Beijing has very bad air pollution. So after we wrote it, in 6 months, it's been downloaded 3,800 times. And now it's cited by 940 papers in 10 years. So oral communication, presentation. So we have under Center for Filtration Research, semi-annual review meeting. That means that we have 2 meetings per year every 6 months, and all the students need to make a presentation of what they are doing. So they have 2 chance every year to present to a group of 60 to 80 senior engineers from our CFR companies. And annually, I send them to a major conference to give presentation. And also, I always want them to think about what they are doing and condense it to 3 minutes if you can. And so I call it the elevator talk. So if you happen to stop in the elevator where Elon Musk is in the same elevator, before the elevator reaches the floor, you want to tell Elon Musk what you are doing, that when he steps out of the elevator, he will turn around saying that, make an appointment to see me, yeah. So this is the elevator talk. So you need to condense everything, think about what is important. In 3 to 5 minutes, you should be able to tell people what you are doing. Now, I also mentioned that to prepare for the academic career, try to find a postdoc position, preferably at another institution. I guess sometimes I violate this rule because I want to keep some of my best PhD as a postdoc. But nowadays, I do like to get PhD from another institution because they bring in a different type of perspective. Yeah. So here's one of my American students giving presentation. He did a good job. He is at NIOSH now, National Institute of Occupational Safety and Health. And graduation. So this is actually in Xiamen, Institute of Urban Environment. They have an office for me overlooking the bay. They call it academician workstation. So collaboration. Now I should say that the whole is greater than sum of its parts. Actually, quoting Aristotle. So 1 plus 1 is greater than 2. Interdisciplinary collaboration can expand your horizon. I understand that PAIR is considered hiring interdisciplinary postdoc, right? So this is good. So your advisor can teach you everything about the field. But if you are interdisciplinary postdoc, you can collaborate with another interdisciplinary postdoc. And then it's a small world. International collaborations can help to solve problems and advance one's career. So I want to give you some example of that. Okay. So here are the example. I use myself as an example. Yeah, one time we have a conference, international conference in San Francisco. So in the evening, I get together with 4 professors from around the world in one of the restaurants on the on the San Francisco Bay. And so through discussion, we find out that we actually all have daughters about the same age. So, for example, from France, Germany, Japan, Austria, and I have 2 daughters. So we decided that maybe we should send our daughters to each other's family during the summer. So here, this is in Austrian Alps skiing, German garden, and in the French mountains, and Minneapolis with a tourist attraction. And so guess what? They go around and soon they grew up, and so we cannot use them as our ambassador. We have to be ambassador ourselves. So guess what? We decided that we'll visit each other's family as our own ambassador. So every 2 years, we went to Japan, to Burgundy, France, to Vancouver, Canada. We have a condo there, and then Berlin, Germany. So this is a very good, and along the way, we talk about all different type of idea. Guess what? Collectively, we received many international awards. Professor Fitzan and I received Max Planck Research Award. That's the highest award in Germany. And also I received the Alexander von Humboldt Award for Senior US Scientist, also from Germany. Fuchs and Memorial Award, that's the highest disciplinary award conferred by American, Japanese, and German Aerosol Association. And Michel Proupit, he came with Professor Picard with the condensation particle counter. And now this becomes the most widely used counter for measuring submicron particles. And Professor Kosaka in Japan received the Japan Imperial Medal. And then I received an Einstein Professor Award by the Chinese Academy of Sciences. And then International Aerosol Association set up a Fitzan PUI TSI Award for international collaboration. So this is a photo we took when we received the Max Planck Research Award. And so we thought that we should really encourage scientists to collaborate with each other internationally. And also, we don't want to see a German scientist working with a French scientist that they can take a train 1 hour later to see each other. So we thought that it should be intercontinental collaboration. So this make it higher chance for Asian to collaborate with European, to collaborate with US scientists. And where's the money coming from? Actually, Heinz and I, we developed this surface area monitor, and then we told TSI that don't pay us a royalty. Why don't you put that royalty amount into a fund to set up the FISAN PUI TSI award? So TSI put $75,000, that's many years ago, and into this award fund. And then it's only presented once every 4 years, where International Aerosol Conference is held. And the next one will be held in Xi'an next year, for those of you wanting to go. So this award, since it's present not very often, so I think the award fund is growing pretty big. So the awardee will get quite a bit of money if they get it. Okay, so next, I'd like to give you some personal story about myself and my family. How do you like that? So this is my eldest daughter, Christine. She was one of the ambassadors when she was young. And now I said that she's more famous than me. She's an orthopedic surgeon. And the reason I said that she's more famous is that one time I go to Macy to buy some clothing and go out to check out. And the clerk, I give the clerk my card. They take a look. Is Christine your daughter? I said, yes, because there are not too many PUI. She fixed my hip and it's working very well. And then and another time, our new neighbor came and she said that Christine fixed her hip 8 years ago, and it's working very well. And University Foundation Vice President, when I was eating lunch, he came to me, he said, Christine fixed my hip. Next, I'm going to ask her to fix my knee. So I asked Christine, did he fix his knee? She said, I cannot tell you my patient. Yeah, so anyway, yeah, you know that she can actually operate on 7, 8 patients a day. So just multiply by how many patients per year, multiply by another 10. So she has thousands of patients and everybody just love her. So that's why I said that she's more famous than me, yeah. So anyway, with the international exchanges, she understands the importance of international experience. So she actually enrolled her daughters, Elena, in Chinese immersion school. You know that Christine, she grew up in US, so she cannot, she doesn't know 普通话, she cannot write Chinese, and she understands a little bit of Cantonese. When we yell at her, then she understands those yelling. So she understands the importance of learning Chinese. So she enrolled Elena in a Chinese immersion school. Now this is very good in Minnesota. Our public school doesn't cost any money to enroll the children. They even have Chinese immersion school that when you go, every day you speak Chinese, you write Chinese, you sing Chinese, you dance Chinese. So guess what? One time, Alina wrote a story and give it to my wife. So I don't know if you see, can you see them? Now, she actually knows how to do this pinyin, 对不对？ So when she cannot write it, she just use pinyin, and we don't learn that as when I grew up in Hong Kong. We don't learn how to do it. So my student, Chinese student, said that she did it very correctly. So my wife cannot quite read it. So guess what? I take a picture of this and use AI to translate it. So I just read you in the middle. Xing Xing lives with her grandma. Every night before bed, she looks out at the window at the stars. She always thinks, what kind of place is that faraway place? One day, Xing asked her grandmother again, Grandma, where's the faraway place? Grandma smiles and said, it is a place where all the dreams begin. And Xing tilted her head and asked, can we go there by bus? And so on. So translation is perfect. And in fact, at the end, it summarized. It's a sweet, imaginative story about curiosity, dreams, and the encouragement of a loving grandmother. So this is great. And learning writing is very important. I know one Chinese scholar in US, he would like to move back to mainland. He speak 普通话 with his son every day, so the son understand 普通话 very well, but then speaking very well, but he cannot read and write. So when the father want to come back to mainland, he said, I don't want to go because when he walk around, he cannot read the sign. So it's important to know writing. So I think 1.5 years ago, I took the family around to Xi'an, to Yancheng, where the second generation sources for removing PM 2.5 is built. So we are very fortunate that we have 3 children. There are 3 spouses, each giving 2 grandchildren. Their age are 8, 9, 10, 11, 12, 13. And all 14 of them live within 15 minutes away from our house. So we are blessed. One reason is because Minnesota is the home base of many Fortune 500 companies. So husband and wife professionals, they can find good jobs in Minnesota. And the next one, I guess my time is running out. Do you want me to continue? Okay. So you know that 10 years ago, I have the idea of having a glass skirt with a power in here. So during the daytime, the sunlight go through the glass plates and warm the air underneath it. And the glass plate is tilting higher in the middle. So when the hot air rises, it go to the middle. And then we put in filtration systems around the outlet of the tower so that there's a huge amount of airflow coming in, and then a filter will remove the particle. So if you look at here, let's see, okay. I was going to show you animation, but doesn't matter. So we actually built one in Xi'an, one in Yancheng, and two in India to provide clean air for the very polluted city. And then now we are focusing on taking out CO2. Now, you know that CO2 concentration increased by 50% since the Industrial Revolution. It's doing something, isn't it? There are a total of 35 billion tons of CO2 emission every year, with a net increase. Forests and ocean can take out a bunch of it, but still there's a net increase of 15 billion tons to the air. And I'll show you this later. And then we are talking about the need of removing gigatons, billion tons of CO2. And now, one thing good is that Switzerland has a carbon tax of $130 per ton of CO2, and US tax credit of up to $180 per ton of CO2 when you capture directly from the atmosphere. Now, many of the current approach is to take out the CO2 from the process, which has a much higher concentration. So it's much cheaper to do that. But taking it out from the atmosphere will be very expensive. So now this is the American Physical Society. They make use of this the contact tower, not a tower, but contact ratchet ring setup, and with sodium hydroxide, and then they need fan to blow large amount of air to take out the CO2. And so in the end, they decided that economically it's too expensive because they need to use fans to blow the whole atmosphere, the whole world's air through this. So, however, for us, we use sources, our tower, because we don't use fan. We just use solar energy to move a lot of airflow in. And then inside there, we will set up this type of contact method. And so this is what I plan to continue to promote using my PITCH CCC to work on that. And you know that it's very bad now. Most scientists want to keep the surface temperature in the Earth to be below 1.5. Last year, it exceeded 1.5 already. So there's definitely a big need to take out the CO2 from the atmosphere. So we are proposing to set up a 1 kilometer diameter tower that can remove 1 million tons of CO2 per year. And then beyond the 1 kilometer circle, we'll put in enough photovoltaic panel to generate electricity to process the chemicals, which is very energy consuming. So by doing that, we don't need fan, and we have electricity to operate the CO2 absorption and regeneration of the solution. And based on the carbon tax of 130 per ton of CO2, we remove 1 million tons. So we'll generate 130 million per year of revenue, so that this could help to offset the capital costs if you amortize it for 20 years. And then So the proposed CO2 sources can be self-sufficient in energy requirements and economically, because you have enough electricity and you have you don't need fan to blow the air in a tower. So I will continue to push on this, and because in the end, we need to build hundreds of this around the world to take care of it. So in summary, Particle Technology Laboratory is a leading research lab and has trained many outstanding alumni and prepare for a successful career focusing on PITCH, CCC, and international collaboration, help to advance career and develop lifelong friendship. Thank you very much.
Thank you very much, David. It's a very inspiring talk. Now we'll have the Q&A session. Please take a seat. You have microphones just on your seat. Just have any questions, please raise your hand and you can ask. Right. I mean, you talk quite a lot about the successful stories, right, in your career. But I believe the more success you have, it also means the more failures you have. So how do you turn the failures into success in your career? Maybe you wanted to give us an example.
How I...
Yes. Sometimes turn the failures. You know, for example, you talk about when you did your PhD work, you have also a lot of difficulties. And then finally, you made this very small aerosol meter.
Yeah, I still remember one time that I tried to coat, you know, the DMA has two cylinders, one inside cylinder, one outside cylinders. I tried to coat the inside cylinder black so I can deposit fluorescent particle, look at the location where the particle are deposited. I put it in a machine, it's a drill bit, and let it rotate so I can spray this black paint over it. Guess what? Let's go. The whole thing shoot away and broke the whole thing. And I was so angry and depressed, and talked to my advisor. Advisor just laughed and saying that, well, do it again. And so I have a good advisor, Benjamin Liu, who passed away just 3 months ago at 92. Yeah.
So the encouragement from your advisor is very important, right?
Yes. Yeah.
We have many professors here. Always try to encourage your students.
Yeah. So it's totally acceptable to make mistake, and yeah. And you know that I teach a measurement lab. One time, well, I always like to use the example of one of the Mars landing missing the target, and later on they find that there's a conversion error between meter and foot, and the whole satellite missed the Mars. And just imagine the engineer that do the software, and must feel very bad. Yeah.
So, Professor PUI, you mentioned many things in educating very successful students, and not only in the universities, but also in industry. And then the title of your talk today is preparing for a successful career, starting with your graduate thesis. And thinking about thesis, and you also said that allow students make mistakes. I think professors can also make mistakes. So I found it very difficult to match the thesis topic and the student. So we make mistakes by giving students wrong, too difficult or too easy topics, for instance. So I mean, this matching side.
Yeah, will be difficult. I have a postdoc. He's very good with software. So he's developing machine learning to predict filter efficiency. I keep on asking him to do some experiment, and he's doing some. It's slow, but eventually now he has developed something that is very useful. So it's now trying to contact TSI to develop that into a commercial instrument.
Basically, it takes time also for supervisors to realize the student's background.
Yeah. So we like to develop the student to have a broader experience. So they don't just work on software. They need to learn about broader scope.
There are also quite a few questions from the crowd because today's lecture is also broadcast through the crowd. So the first question from the crowd is, how could one select the topic of the thesis, which could match the development of the technology requirement and also the market requirement? I mean, should you just select a research topic which will really gear to your future job?
So we are fortunate to have a lot of companies sponsoring our research. In fact, most of the research that we are working on are suggested by the company. They want us to try this out, try that out. And some become successful, some not so successful. So the student get to work on a broad variety of topics.
So there's also another question about how you could evaluate the potential for commercialization. I mean, you might have developed some interesting results, like new materials or new algorithms for like AI the type of technology. So how do you know this technology can be commercialized?
Yeah. So we actually, in this Center for Filtration Research, we develop many different good ideas, but we don't patent all of them. We only patent just selected few, and based on what we think will be important. And I'm quite sure that many of the ideas the company do internal development as well in parallel and develop into a product. So that's totally fine with us. We don't need to take credit for this product or use my idea or something like that. So what is more important in scientific research is to publish.
Yeah, talk about the result. There also a question about that. They said that, of course, your result can be in patents, theses or papers, or even prototype, right? So now if you think about in the field of semiconductors or the biomedicine or artificial intelligence, so which one you think is a better result?
Yeah. So at University of Minnesota, we are fortunate to have a patent commercial technology office that they keep on writing me, oh, you have good idea that we can file a patent and so on. So we provide them with some idea which they file a provisional patent, which is very inexpensive. And then the next stage, when they actually need to file a patent, then it becomes expensive. So just in the last few months, they said, okay, here are 5 of the provisional patents that we have. Which one do you want to keep? So I said, keep this 2, cancel the other 3. So it's just like something that you try to develop. Hopefully they are successful. But actually, yeah, it's really not that important. But it's good that at the university, we have an office to push you on that. One time I was called the inventor of the year, university, but I don't make a lot of money out of patents. It's just to show in my CV that I have 40 patents. Yeah, but how much money do I make out of that? Not very much at all.
Yeah, but the question is, if you could file patents or publish papers or make a prototype of a machine, so which one you think is more important?
Yeah, to be able to make a prototype and demonstrate the technique and write some papers. And I should mention to you why sometimes the patent doesn't bring too much money to your pocket. Now, Chen Daren and I, we developed using electrospray to produce nanoparticles. And the university filed 12 US patents to use it to make nanomedicine. If you make the medicine in the nanoparticle form and put it in a tablet, when you take the tablet, it dissolves in your body right away. So we have 12 patents. We started a company called Nanocopia, and then we developed multiple jets to make a lot of material. And it's very slow. I think our manager is not so good. We started out with Chen Daren and I and 2 managers. And so we each own 25% of the company. Guess what? This company, over 12 years period, they haven't gained any revenue until recently. So there's a Minnesota real estate tycoon who invested, I think, $50 million into this company. Guess what? Our 25% is now worth 0.01%. So you don't make money out of that. But then I have 12 patents. I should mention that one thing that is good is that FDA has approved one major cancer drug called dasatinib. It's a cancer drug with $2 billion of market. And so the company was able to produce, and then through the testing showed that nano formulation indeed is a lot more, if you better efficacy in the drug. So now there's a factory in Taiwan and Canada making that medicine. Hopefully they are finding other drug to too. One thing good about this particular drug is that the traditional formulation patent expire this year. So by having the new formulation, the traditional formulation expired this. But so that's what I mean, that don't expect to make a lot of money. Sometimes it's the luck, and also your team. You need to good manager and to help you.
Right. Yeah, because we often heard from the news media, somebody established a company, then overnight it becomes a billionaire. And therefore, we are very excited that one day we'll be one of those. But in reality, in fact, many companies, I think over 95% of our companies did not survive after 3 years. It's a very difficult one. But you should not be discouraged. You're young and you should have the passion and try to make your dream to come true. Okay, any questions from the audience? Yes, please.
Hi, Professor David. I'm a PhD year 1 student from mechanical engineering, and thanks for your speech today. I learned a lot of tips for my talk future career. And regarding to your speech, you've mentioned we should build connection with industries, even we are doing academic things, right? So could you please give us some suggestion or tips? How can we build connection, like from point of view from a professor standpoint or from a student standpoint? Okay, thank you.
I think, yeah, sometimes you need to have the spirit of collaboration, that you welcome that opportunity. And if you look at Apple and many companies, they started as some fellow students getting together, trying something out, and then slowly make a good product out of it. So you just need to have that idea of international collaboration is good for you and for your career. So you need to have the right attitude. And of course, your advisor is always the most experienced one. He over the years, he learned a lot of things, and he a good resource person too.
Okay, so from a student point of view, we should explore also out resources like to do internship or have more conference experience like this, and persuade my professor to give me more opportunity to get exchange.
Yeah, that's why I think last year PAIR talked about sponsoring interdisciplinary postdoc. That's a good idea. So you get together another postdoc who has totally different background, and then 1 + 1 be a lot more than 2. So you just need to have that attitude and spirit of collaboration.
Thank you.
Definitely, collaboration is very important. I mean, as a student, you can try to find opportunities. You mentioned about attending international conference is a very important one, but there are also some international project, and you could ask your supervisor to sponsor you, give you an opportunity. I myself, when I was young, and I joined a international project with more than 20 European countries together. and I knew quite a lot of people at that time. And those people now, most of them becomes professors all over the world. And that's just like a Professor PUI gave you an example, because those people, you work together, then you will receive an award, things like that. That's a very important aspect. On the other hand, you learn the experience from other people. You don't do everything, and then you work on the same project. You see what the development in the other side. For example, if you do the theoretical research, you can see what the experimental research is doing. So in this way, you learn quite a lot from them. And if you are lucky, for example, working with the Professor PUI in the industrial consortium in his lab, then you have more than 20 companies from the industry. And I myself, in the past, I also had a consortium. So many students just work in this consortium. Then the industrial people look at your work, they can hire you if you do a good job. And so you don't need to look for a job very hard because your employer is already inside of this lab. Any other questions? Yes, please.
Hi, Professor Pui. First of all, I'd like to say it is impressive to see the remarkable achievement you and your student achieve. And I have one question that for young researchers, we are now facing all sorts of different evaluation system. So how can we build the confidence when we're starting our academia career? Do you have any suggestions? Thank you.
You mean because of the evaluation system that people may not agree with what you're doing?
There's a lot of different criteria, different evaluations. So how can we insist or know that we are doing the right things or directions when we are starting the career?
Yeah. So it's true that a lot of the time your project is funded because the review committee likes you, yeah. And so, yeah. I'm trying to think how, usually the review committee, they don't tell you who is on that committee, so you just need to try it and hope to. Yeah, sometimes when you write proposal, when you write enough of it, you know how to tailor it so that the reviewer will not have strong opinion about what you propose in terms of whether they agree or not. Yeah. Yeah, it's true that if you have a committee that understand what you're doing, you have a much better chance. And I don't know how to, because it's totally confidential. I don't know how best to pick it. Yeah. Yes.
Good morning, Professor Chen and Professor Pui. So thank you so much for sharing about the particle technology and your experience as a learner. And so you have shared with us that the quantum technology, which will become another big thing in future after AI. And since we seldom have chance to talk about it, and we sometimes hear about this word in movies, and like, is there any chance we can talk more about the quantum technology and like, why would it bring impacts like AI in future, and how is it related to industries around the world?
The quantum technology?
Yep.
Yeah, actually, I'm not an expert in quantum technology. And for my student, he started out doing semiconductor manufacturing and then slowly get into quantum. And one thing for sure is that he is a very smart person and he reads a lot. Yeah. Sometimes, like when I invite him to come to Minnesota to give a lecture, and we have 30-some professors wanting to talk to him from 4 different departments. And he understands all the questions, and he said, let me read about it tonight. So he still read a lot, trying to understand what is the state of the art. So sometimes when you talk to some of the colleagues that may not be doing similar things, but then they have different point of view. So you try to understand that and incorporate that into your research. Yeah.
Thank you so much for the response.
Maybe last question. Anyone? So if not, I'd like to, give Professor PUI another round of applause. So Professor PUI, to thank your contribution to this pair seminar, we make a special souvenir for you. It's a plate, have your name and the title of today's lecture on it. All right, okay, thank you very much. PAIR organize distinguished lectures and seminars from time to time, and I will encourage all of you, to pay attention to our next announcement. And I'd like to thank for your participation, especially for those who asked questions today, which make this seminar even more interesting. So thank you very much, and this seminar is adjourned.